Oh, don't you just love cartoons about statistics? This is a good one. I think we should give it another shot. We should break up, and I can prove it. Our relationship, oh yes, going down. Oh. Maybe you're right. I knew the data would convince you. No, I just think I can do much better than someone who doesn't label her axes. Oh. Don't you just love statistical cartoons? All right, so anyway, we are going to do section 3 in chapter 2 today. We're going to be organizing quantitative data. The last thing we did in section 2, we did qualitative data. That is data that is not numerical. You can't do mathematical operations on it or anything like that. So today is quantitative data, where it's going to be all numerical data. Okay, we're going to talk about 3 different techniques for organizing your data. We're going to do single value classes, we'll do limit classes, and we'll do cut point. Okay, and talk about what kind of data you should use with all of the various different kinds. First, let's talk about single value. Single value data. If you look down at the bottom of page 51, okay, bottom of page 51, there's a whole bunch, pardon me. Top of page 51, we're looking at the number of TVs per household. And you can see the 50 randomly selected households at the upper left of page 51, okay. Notice that the number of TVs per household of those 50 randomly selected households vary from 0 up through a total of 6 TVs, okay? So it's 0 through 6, your total number of choices. You're in a bar graph. When you do a bar graph, your total number of bars would be 6. You do a pie graph, your total number of pieces of the pie would be 6. 6 is a very manageable number, and you can keep the groupings at single values, 0, 1, the whole way up through and including 6. And I said 6, there would be a total of 7 actually. But this data would be very, very good to do in single value grouping. You can see the frequency chart there in the middle of page 51, okay, and the relative frequencies for the 7 different categories from 0 through 6, okay? It's very useful for discrete. That means, if you recall from our last time together, no decimals. It's countable data, no decibels, mostly whole numbers, and few of them, small number of distinct values, okay? That's called single value grouping. All right, next is limit grouping, where each value goes into a class between a lower limit and an upper limit. Useful when there are too many values to use single values. So now, go back to page 51 before we get here. Go back to page 51 down at the bottom. If you look at the days to maturity for 40 short-term investments, look at all those different numbers, okay? I have no clue how many different ones there are, but there's probably in the neighborhood of 25 to 30 different numbers. Do you want to do a bar graph with 25 to 30 different bars, or a pie graph with 25 to 30 different pieces of pie? I don't. So look at the top now, page 52. Limit grouping is very useful when there's too many values to use single value grouping. Top of page 52. You can see the way it's grouped. We've got days to maturity, all the numbers between 30 to 39, 40 to 49, 50 to 59. You with me? Okay. It cuts it down to 7 different groups, which is very, very manageable. Okay. Now, once again, though, it's useful for whole numbers only. Okay. But when you have a whole bunch of numbers and you're going to get a whole bunch of bars and pieces of pie, you want to go to limit grouping. Okay, a couple of things about limit grouping. The class width is the lower limit minus the lower limit of the next smaller class. All right. In other words, what's the class width of 30 to 39? If you count those numbers, 0, 1, 2, 3, the whole way up, There's actually 10 different numbers, okay? And that's why they say from the lower limit of one group to the next lower limit, 30 up to 40, you subtract and you get 10. Or you simply count on your fingers, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. That's a total of 10 different numbers for the class width, okay? Obviously, forgot the class mark. The class mark is the average of the lower and upper limits, okay? So the average of 30 and 39 is actually 34.5, okay? It is not 35. You add them up and divide by 2, okay? Try to keep the class widths identical. Do it in a nice, consistent pattern, 30 to 39, 40 to 49, and so on and so on and so on, okay? Of the class 70 to 79, the lower limit would be 770, the upper limit, 79. The class mark is the average of 70 and 79, which would be 74.5 when you add them up and divide by 2, okay? And the class width is 10. You can either get that by counting 0 through 9 on 70 to 79, or you can subtract 70 and 80, okay? And you get a class width of 10. We'll come back to these and do more examples in a bit. Now, cut point grouping. Classes are stated in this fashion: 25 to under 30, 30 to under 35, and so on and so on and so on, okay? Cut point grouping is very useful for decimals, okay? Especially, well, the really neat thing about cut point grouping, you can use cut point grouping even for limit grouping. Limit grouping, instead of saying 30 to 39, you could have said 30 to under 40. Are you with me? So cut point grouping is kind of a catch-all thing, but it's mostly used for decimals, but you could even use it for limit grouping. Smallest value in a group is the lower cut point, same as the lower limit. In limit grouping, the upper cut point is the lower cut point of the next group, okay? So in other words, in 25 to 30, 25 is the lower cut point, 30 is the upper cut point, okay? So 25 to 30, 30 and under 35, 25 is the lower cut point for the first class. Upper cut point of the first class is 30. Cut points used primarily when there's decimals. Look at 2.14 on page 53. 2.14, we're talking about the weights of 18 to 24-year-old males. And notice all the decimals. Look how they made their chart. 120 to under 140, 140 to under 160, and so on, okay? And they end up with 8 bars or 8 pieces of pie. Okay, very, very manageable. Okay, I mean, there's different ways you can do these, but you should try to strive for in the neighborhood of 6 to 8 bars or groups. I mean, it'd be kind of silly to go 120 to under 180 and 180 to under 240. You're going to end up with 3 groups. What does that show you? What does that tell you? Not very much. Always try to shoot for in the neighborhood of 6 to 8 different groups. Okay, difference in the cut points is the width, 30 to 35, just subtract. The midpoint is the average, 30 to 35 would be 32.5 for the midpoint or average of each group. Okay, some other things about quantitative data that's a little bit different from qualitative. When you do your bar graph, it's called a histogram when it's quantitative data, when it's numerical data. For instance, it's kind of hard to see these, but I think these are favorite colors or something like that. And this is the number of people that like those colors, okay? These are colors. These are qualitative data that we did our last time together. And notice the bars did not touch when you do qualitative data. But over here in this histogram, this is miles per gallon, okay? Miles per gallon and how often that occurs. Like, say it's the number of trips you take, okay? Like if you go 5 to 10 trips, you're going to get 2 miles per gallon or something, or you 2 times you get 5 to 10 miles per gallon. And here, that's 1 time, sorry, 1 time. And then roughly 2 times you'll get 10 to 15 and so on. You get this nice looking pattern, okay? Miles per gallon are dependent upon different factors, but you can see, and you would want to see when you get your highest miles per gallon, which is over here, and what are the factors that occur there. Quantitative data is always done with touching bars because usually, and I think the example I used the last time we were together, is if you think about the temperature over the day, it's going to start out cool and it's going to get warm and then it gets cool again, kind of like that graph, all right? So it's very, very useful to make the bars touching so you can see the continuity between the different categories. Okay, what about dot points? Dot points. You draw a horizontal axis, something like this. You place coordinates on it. Okay, now notice there's no title here. There should be titles. All right, the other thing you want to do, and I really emphasized this when we were doing box plots or box and whisker graphs, you remember those? Make sure your x-axis is consistent. For instance, here, I don't think you can probably see it. It's 5, 10, 15, 20, right? Here, the number of children in a family, 1, 2, 3, 4, 5. Make sure it's consistent. This should not read 5 and then 10 and then 12. It's got to be consistent. If you're going to go 5, 10, then 5, 10, 15, 20. If you're going to go 1, 2, 3, you got to keep going, increasing by 1. All right, so make your scales consistent. All right, then you simply put a dot for each one of the data. And the dot plots should look like bar graphs. Okay, should look like bar graphs if you do them correctly. Pretty easy stuff here. That's one real fun part about statistics. Chapters 1 and 2 are incredibly easy. 3 and 4 get a bit more interesting. All right, so now let's do a dot plot for the following data. Okay, if we're going to do a dot plot here, these are the prices for cameras in the Susquehanna Valley Mall. All right, so you do an x-axis. Notice what we have here. It looks to me like we have data going from roughly 89 up to 120. Okay, so I'm going to do something in this fashion. I'm going to do 90, 100, 110, and 120. Here would be 95, 105, 115. Okay, now we just do dots. 89 would be to the left of 90, we put a dot. Okay, I've got 119, which would be here. I've got 120 here. I've got a 99 here. Okay, 110, another 110. So I have to put the dot above it. 120 above it, okay, 100 here, 99 and 99, a couple more of those right above it, 120 and a 119, okay, that is a dot plot, all right. Which grouping technique should we use here? Well, how many different numbers do we have? We have numbers from 5 through 10, which ought to be 6 different numbers. Very, very manageable for single value grouping. Okay, very manageable. Decimals, right away, decimals, cut point. Got to be cut point. You have no choice. Now look at all the different numbers you have here. My word, we've got numbers from 10 up through the middle 30s. I mean, you're talking about a potential of 23 different numbers. You don't want 23 different bars. You don't want 23 different pieces of pie in a bar graph or in a circle graph, pie graph. So you would do limit grouping here. You know, you could do limit grouping and what's the smallest one? I see 10, right? So we could do something like 10 through 14, for instance, 15 through 20. That's not going to work because 10 through 14 is 5, and this is 6. So this would have to be 19, 15 to 19, and then 20 to 24. I think that's working better because this is a distance of 5, 5 here, 5 here, and so on until you get up to 40. Okay? All right, I think that's probably a good way to do it. Okay. Now, what about stem and leaf diagrams? Okay, a stem and leaf diagram is a way of classifying your numbers. It takes you less time to write down all your data. Okay, it's actually a time-saving device here. What we do is we take a data item like the number 43 and we classify 4 as the stem and 3 as the leaf. Okay, take your first number as the stem and the second number as your leaf. 3-digit numbers can be done with 2-digit stems. For instance, 245 would have 24 as the first part and 5 as the leaf. Okay? You write stems in order to the left of a vertical line and leaves to the right, also in order. See example 2.17 on page 58 and 59. Let's take a look at those. Just to give you an example as to how this is done, and then we'll do one. Down at the bottom of 58, you see all that data. Lots and lots of data. Days to maturity for 40 short-term investments. Okay, then look what we've done for the stem and leaf graph over on page 59. We've taken the numbers that started with a 3, like 38, 36, 39, and you see what we've done. We draw a vertical line, we put a 3. Okay, then the 6 over here, this is the number 36. Put an 8, that's the number 38, and put a 9, that's the number 39. Okay, I think there's only one with a 4 on it. 47 would be 4 and 7, right? Okay, very quick, easy way of doing it. You can see on page 59, you try to keep everything in order. Keep the numbers in order vertically and keep the numbers in order horizontally also. I'm kind of rushing through this because I'm assuming that most of you will find this to be fairly simple. Oh, if only chapter 4 was this simple. Okay, so do a stem and leaf diagram, 1 line per stem and 2 lines per stem. So let's first start with 1 line per stem. I'm going from the numbers 11, or numbers that start with a digit of 1 to digits that numbers that start with the digit 2 to numbers that start with the digit 3. So basically what I would have is a 1, a 2, and a 3. Now because there's only 3, I do not think this would be the best way to do it. But anyway, let's complete it. So in numbers starting with 1, I've got 11, I've got 13, 14, 16, 17, and 17, and 18. Okay? Everybody able to see that? It's starting to look a little faint. I may have to get another marker. Numbers starting with 2. I have 2 20s. I have 2 21s. See what I'm doing? 21, 21, got it. I have 2 22s. So 2, 2. I have a 23, a 25, 2 26s, and a 27. Okay? Now in the 30s, I have a 30, a 31, a 32, 2 35s, and a 36. The problem with this, it's only 3 lines. It's only like a bar graph with 3 bars. I don't think that's showing you the data as best as we could have done. So now let's do it with 2 lines per stem. So I have 1, 1, 2, 2, 3, 3. Okay? And what I'm going to take is I'm going to take anything from 10 up to 14, 5 numbers. 10 up to 14 would be, there's no 10 here, so it's 11, 13, and 14. And then from 5 through 9 would be 16, 17, 17, and 18. Now here, I'm going to go from 0 through 4. So I have 20, 20, 21, 21, 22, 22, 23. And then I have 25, 26, 26, 27. For the threes, I have 30, 31, 32, 35, 35, 36. And I think that's much, much better in showing you the data. You can see this bar is higher than any of the other ones, okay, which is not shown as nicely up here. Okay, so that's a great way to do your stem and leaf diagram. Okay? All right. Do a stem and leaf diagram, 2 numbers per stem. So if you're looking on this one, we have numbers starting with like 21, and we're going the whole way up to 30, it looks like. Okay, so what we're doing, I don't see any 200s, right? Okay, so we have 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Vertical line, okay, growing ever more faint. Here we have, how shall we do this? Let's just do the 21s first. So I have 215, 216. Are they the only ones? I think. So I have 215, 216. See it? Okay, now starting with 220s. 220s, I'm trying to see, make sure I don't miss any. So I have 223. I have 224, but I got a couple of those. Okay. So I have 2 224s. Okay. I have 2 225s. Correct. 2 225s. Okay. With me? Do I have any 226s? Yes. One of those. Then I have 227, one of those. Is that it? I think that is it. Okay. What have I got for the 230s? For the 230s, I have 230 and 234. So I have 230 and 234. Is that it? Looks like it. How about 240s? Do I have any 240s? 240s, 240s, 240s. None. Do I have any 250s? 250s, 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 250s. None. How about 260s? 260s, 260s, 264 is the only one. Ugh, this is some weird data. 270s. I've got one right here, which is 278. Do I have any 280s? 280s, 280s, 280s. A 287 and a 288. Is that it? 287 and 288. Notice how I'm putting the numbers in order, both vertically and horizontally. 290s. Okay, I have a 290. Okay. I have a 291, and only one of those. I have a 294 and 295. Is that it? 294, 295. I think so. And a 300. I only have one of those. Okay? That is a stem and leaf diagram with 2 numbers per stem because they're 3-digit numbers. Okay? So, once again, couple of easy topics today. Homework problems all in the book. No extras.